Take 3 of this video. Right, so what I've created for you here is a graphical representation of simultaneous linear and quadratic equations, and I'm going to show you how it works. And this graph is fantastic because it's on Desmos, which I love. So you can see here that the red graph is a linear graph. Just reload it. The red graph here is a linear graph, and the green graph is a quadratic graph. Now I'm going to move, I have sliders in here so I can move the graphs around. So you can see here that the red graph intersects with the green graph twice in this case, or if I move the red graph down to here, it will intersect roughly once, not roughly, exactly once. And if I move it further down here, it intersects at no times. So this is just like before when we solved quadratic equations. We could have quadratics which touch the x-axis twice, or once, or no times at all. So exactly the same thing happens with simultaneous equations. So the way to solve this, and I'll show you how it works first, is that if we combine the graphs by using substitution, you can see that we can have a purple graph here, which is the combination of the two. And I'll show you how to do that later on, but I want to show you why it's so important. As I move this red graph up and down, oops, I have to turn on another feature. Here we go. So you can see here that the red and the green graph intersect, all right? And the purple graph actually cuts through the x-axis at a certain point. And funnily enough, it cuts through directly below or above in some cases where the two graphs intersect. All right, now the dotted lines show us exactly where that is. So you can see here that this x-intercept on the purple graph is directly above the intersection of the red and the green, and the same with this one. So this helps us find out the intersection points between the two graphs. So we'll put this to the side for now, and we'll leave it there so we can see it and be reminded. And we're just going to practice with an example from the book. So this is just the standard example with a linear equation like this and a quadratic equation like this. All right, now we're going to use substitution to solve these, which means setting them equal to each other across the equals sign. Whoops. Equals x squared minus 8x plus 12. All right, we're going to move the like terms across. Going to move that across to there. That'll leave us with 0 on the left-hand side. The square won't have a like term. The minus 2x becomes a plus, that gives us minus 6x. The plus 4 becomes a minus, that leaves us with 8. Now, we have a 0, which means we can use the null factor law. So we're going to solve this equation, factorize it first, which in this case we can do by sight. The solutions are that, the factors are that. Therefore, x equals 4 or x equals 2. Now, remember back at this graph here, we can see that the purple graph was above or below. And what that means is we don't know the height, which is the y value. So we have to substitute those two x solutions back into one of the equations to find the y values. So first of all, we'll substitute x equals 4 into the linear equation because it's far easier to work with. So we'll sub y equals minus 2, 4 plus 4, which equals minus 8 plus 4, which equals minus 4. So the solution here is, oops, not x, sorry, coordinate 4, comma, minus 4. Now this solution, we do exactly the same thing. Sub it into the x value of the equation, simplify, and you can see here that it's going to be 0, so therefore the solution is 2, 0. What this means is if we were to flip back to a graph, we would see that the two lines, the parabola and the equation, and I'll see if I can draw this by hand, the two lines would intersect at 2, 0 and 4 minus 4, which I'll say is here. We have a parabola which goes through it. 12 goes through at 6, and it goes through at 2. So it's going to look something like this. I've missed that red intersection point, but just bear with me. Then I have a linear equation, which is a negative slope. Oops, that's completely off. I'll join up those two like this. So this is what the two graphs would look like if I drew better, but you can see here that the two graphs intersect at that point there and that point there, which are 4, -4 and 2, 0. So just to recap, your steps are as follows. We set the two equations equal to each other across an equal sign. We gather our like terms. We set it equal to 0. That's what happens after you gathered your like terms. We factorize the combined quadratic if we can, using one of the methods of factorization. This one was done by sight, but we don't forget we could use the quadratic formula or completing the square. Then we substitute each solution back into one of the equations, one at a time, to find the two intersection points of the two graphs. The last step, which I did over here, graphing it, was not necessary. I just wanted to show you that those 2 points were correct. All right, and now I'll show you how to do it on the calculator by watching this video. You'll notice that the answer is already up here. So we need to click on that button there, type in the two equations. They have to be in y equals. So I go back and do this now. Y equals. Same for the bottom line, y equals. Type the parabola in. This vertical line in maths means given that. So it's telling them to solve these two equations given that x and y are the solutions. Then you just hit exe and there's your answer.